All right, folks, we are back. We are looking at 10-2 Part 2. All right, hopefully you were able to get yourself through 10-2 Part 1. 10-2 Part 2 ends up being a little bit more difficult for one reason. The formula for a rhombus or a kite, they are the same. Okay? The formula for a rhombus or a kite are the same. The big issue is neither a rhombus nor a kite formula will be on your reference sheet. All right, now I'm going to show you the picture out of the book so that you understand where they get the formula from. It is diagonal 1 times diagonal 2. Now, most of you have seen base times height for a parallelogram. Okay, base times height, base times height, base times height. All right. Hopefully you'll understand why it's diagonal 1 times diagonal 2 divided by 2. So let's look at this picture. You should notice that here is the big parallelogram, and here is my kite. What do I notice about this triangle and this triangle? See, notice the kite's inside of the parallelogram. What do I notice about this triangle and this triangle? What about this triangle and this triangle? And then lastly, this triangle and this triangle. Hopefully you are telling me that they're all congruent, meaning this triangle and this triangle are the exact same size. This triangle and this triangle are the exact same size, as well as the top two triangles are the exact same size of these two pieces. So in actuality, this parallelogram was cut into how many different triangles? 8, right. How many did we use? We used half of them. That's why this problem is diagonal 1 times diagonal 2 divided by 2, because it's half of a parallelogram. Very similar to a triangle, correct. So their two formulas are similar. Okay. Now in the book, it's written like this. Area equals 1/2 diagonal 1 times diagonal 2. Okay. I write it like this. They are the same. Okay. So understanding what you're supposed to be doing. Oh, it's like a triangle. The difference is how do I know I'm not using base and height? Because you have two diagonals in your picture. At this time, could you please release all seniors that's going on the P-TECH field trip? All right, so here we go. Relatively easy formula, but again, we still start using our right triangle work. And who can tell me why we're using right triangle work? Well, I'm going to draw a rhombus, and you tell me what is the one rule a rhombus and a kite have in common about their diagonals. And I'm hoping you said to yourself that both of these have diagonals that are perpendicular. Correct. That's what makes them use the same area formula. And notice, here I will have 4 congruent right triangles. Here I will have 2 congruent right triangles up top, 2 congruent right triangles on the bottom. Yes, this is where we get into a lot of right triangle work and trying to put together your quadrilateral rules and your 30, 60, 90, 45, 45, 90 sine, cosine, and tangent rules. All this stuff starts coming together. All right? So hopefully you've retained a lot of that information. If you have not, we're going to have to work on it. All right, so we're going to look at the first one here, and it's a rhombus, or it's a kite. Okay, the first shape we're going to look at is a kite, because their formulas are the same. Okay, so there's my kite. And what happens with one of the diagonals in a kite? Hopefully you know one of them is bisected, right? So here's 3 and 3. And then I have this measurement here of 5. And I am wondering what this measurement here is. Okay, now I'm going to go ahead and give it to you this time. It's 2, right? So now I would have to do my area formula. So the area of this is diagonal, see, there's my dyslexia. Diagonal 1, diagonal 2 divided by 2. I always draw my D's and B's backwards, so please forgive me. What is the length of diagonal 1? Hopefully you've told me it is 6. What is the length of diagonal 2? Hopefully you've told me it is 7 divided by 2. So 42 divided by 2 is the area is 21, and in this case, these are all meters squared. All right? And we do the same type of work for a rhombus. You have to make sure that you have the entire diagonal, not a piece of the diagonal. You need the entire diagonal. If they only give you pieces, then you have to put the other piece on. Now in a rhombus, it's relatively easy. Why? Because the diagonals bisect each other. So if I put a 3 here, that means 3 has to go here. And if I put a 7 here, that means I have to put a 7 over here. So this would be 6 times 14. All right? Okay, now what would happen if they gave me the outside pieces? Well, you may even have to use a squared plus b squared equals c squared, and you can find a missing piece. So let's say they gave you this shape and then all of a sudden they don't want the area. They say find the perimeter. Well, now I've got to use 3 squared plus 7 squared equals c squared. Now, do I have to do that for each triangle? In a rhombus, no. Why? Because all those triangles are congruent to each other. So once I find one hypotenuse, I know all of the other hypotenuses are the same because in a rhombus, all the sides are same. So now you understand me when I say, hey, you've got to study your definitions because these are all the things that have to come into your head. When you say rhombus, you have to see these congruency marks. When you see rhombus, you have to see these congruency marks. Those are the things you need to see in your head so that you're able to do the math. The math is not going to be difficult. It's seeing the picture that you're supposed to see and the congruency marks where they're supposed to be. All right? So let's do another problem. This one is a rhombus. And it says my sides are 10 centimeters long. Okay, you can already tell we're going to have to do right triangle work because this isn't a diagonal. Okay, it's one of the sides. And then it says the longer diagonal is 16 centimeters, and they want to know what the shorter one is. Well, the problem is the longer diameter is 16 centimeters. But that's not this piece of the right triangle. How long is this piece of the right triangle? Hopefully you said it's cut into 8 and 8. But see, this is why you have to draw it out. I need the other piece here. So hopefully you know you're going to do a squared plus b squared equals c squared. But you're missing one of the either a or b. It doesn't make a difference. The important one in that problem is making sure that c squared stays by itself. And then we do our algebra again. 64 plus x squared equals 100. X squared equals 36. And then I have to square root it. X equals 6. Okay, so now I have x of 6, which is this piece. But what is the diagonal? It's actually 12. And now I'd have to do the area formula. Okay, the area would be 16 times 12 divided by 2. So many things come into play in this section. Sometimes they give you the diagonals. Sometimes you have to do the right triangle work. Sometimes they're going to give you 45, 45, 90, or 30, 60, 90. Sometimes they'll give you two of the sides, and you can use Pythagorean theorem to find one of the pieces. Then, of course, you have to double it in the picture, and then you have to continue from there. Sometimes you're going to have to do a lot of work. Because in a kite, you might have to do the top Pythagorean theorem, then you might have to do the bottom Pythagorean theorem, because you don't have 4 congruent triangles. You have only 2 up top and 2 on the bottom. All right. What I'd like you to do is, I've done the got it problem for problem 4. you're going to go ahead and start on the lesson check, and then check those answers when you come to class. Remember, you're doing the lesson check this time. I got it 4. You're going to do the lesson check, and then you'll check those answers when you come back to class, and then you'll have the rest of the assignment. Work well.